You see what you in our chat?
Yeah.
What? Want me to play music? Only
Should be.
only emo night stuff. Only sicko mode. Sicko Bamba. Yeah, I'll start. All right, so yeah, I'm just gonna go over some Leetcode interval questions. I've gotten like they're decently like relevant. I've gotten at least one as a final interview question for Bloomberg, and I bombed it so bad. So that's like it's a question I'm gonna do because I should know how to do it well now. That was the like after that, I was like, all right, I actually need to like know how to Leetcode now. So I was stalling for like 45 minutes, being like, oh, I have no idea what to do.
Well, I gotta say something.
Yeah.
I'm in some sort of program called the pilot program for Code Academy. That's why these are Code Academy slides. I'm just supposed to say like this is sponsored by Code Academy. So use Code Academy, everyone.
Yeah. I made the slides and just put the Code Academy logo on it. Okay, so basically for intervals, you want to like exploit their the timing. You want to either sort or do something in that manner. So I'm gonna go over like the general cases for intervals. So you kind of have 6 cases for each interval. The first case, A and B don't overlap. A starts and ends before B. The second case is A starts before B and ends during B, or ends after B starts. And then B ends after it. The third case is A and B completely overlap, as in A, like B is encompassed by A. B starts before A and ends in between A's interval. And then 5, B completely overlaps A. And then the last one, A and B don't overlap, but B starts and ends before A. So these are kind of every question that involves intervals, you should kind of visualize this example and be like, all right, how can I make it to where I either can count all the overlaps or I can get rid of some of these cases or not have to consider all 6 in your code. So like interval problems kind of belong to a group of algorithms called greedy algorithms. This is something I think they cover in algorithm extraction. I didn't take that class, but I took like the grad version. So this is like from the slides. So for interval scheduling, this is where you're gonna like schedule as many jobs as you can that don't overlap. So in this example, you have all these intervals. A goes from 0 to 6, B goes 1 to 4, and so on. And you basically want to find the maximum subset of compatible jobs. So you can't have 2 jobs that overlap, or else you wouldn't be it wouldn't be possible. So yeah, I'll go over some not great algorithms and then the optimal. So some non-optimal solutions. You sort based on earliest start time. So you pick jobs that start first. So in this example, you have some really big job that takes a super long time, but it starts at 0 or it starts at 1. So this algorithm is just going to pick that one, but then it's not going to give you the optimal solution because you have all of these that overlap, and if you just scheduled the small jobs, then you would get like 4 versus 1. The next one is shortest interval, so you just pick the one that takes the least amount of time. Here's a counterexample for that. The optimal solutions, the 2 long ones, and if you schedule the shortest one, it's not going to work. And then even if you do fewest conflicts, that's not going to work. So as you can see, like the 4 right here have a bunch of conflicts, but that would be the optimal solution. So yeah, it all just comes down to like sorting it in the correct way. For this question, you're going to sort it by finish time. And because it's sorted by finish time, no matter what, you're going to get the optimal solution. So if we go back here, if you take the earliest finish time, each job, like you'll be able to schedule it just with the maximum like subset. So you'd take B, then you would take the next, then you would take F, which is the next job that's compatible. And that would be it, I think. Yeah, based on this. I don't think there's another, there shouldn't be another way to do it. Yeah, I think so. It'd be B, E, and then H, I think. Yeah. So you'd sort by start time and then basically remove all the other ones that conflict and then return A. So you can do this using a priority queue. So that's one example of it. I'm going to do like an actual Leetcode question now. So this one's meeting rooms 2. It's a premium question, so I don't know. Does everyone have premium or not? So I can just do it. Like, sure. The other ones aren't. This is just one that like is really common. Like this is the one I got for Bloomberg and I bombed. So, and it's like the most famous interval question. So do you want me to wait and see, like, does anyone have or not? I can just do the answer. No? Good. All right, I'll just do the answer. Okay, so for this, you're given an array of meeting times or intervals, and you have a start and end time for each interval, and you want to return the minimum number of conference rooms required to schedule all of them. So basically, you're going to want to take, you're going to schedule each one, but you're going to want to use sorting and sort by start time, and then use a priority queue to mimic the meeting rooms. So if you start by, if you're like, let's say we schedule these intervals by start time, we're going to take the first meeting room is going to be that one, and then that's going to take the entire time, basically. And then the next meeting room is going to be from 5 to 10, and then that one's going to end, and then you're going to schedule the 15 to 20 in meeting room number 2. For the second problem, you're going to want to schedule this one first, and then that's going to end at time 4, and then you can free up that meeting room and then schedule the next one. So if you sort by start time, then you cut down the conflicts here. You can only have 1, 2, 3. Yeah, these are the only possible cases now, because B can't come before A because it's sorted by start time. A can't come after B, and B can't, or A can't come after B again, whatever. So basically sorting cuts down to 3 cases. So that's one of the reasons you want to use sorting. So I'm going to just write out the base case for this, which is that. Oh, is it really small?
Yeah.
Let's see. Yeah,
That's a lot better. Not better?
okay. So you're gonna check first that it's not empty. So if it's empty, then you don't have to, you can just return 0. You don't need any meeting rooms. So yeah, that's the first case, the base case, I guess. Then I'm gonna sort it by start time. Java's got some good functions for sorting and priority queues and all that stuff. So I'm gonna takes in intervals. And then you're gonna use a like compare function. I'm just gonna use an arrow function because it's a little easier. It's just basically you're gonna sort by start time. So this is gonna sort by start. And then I'm gonna create a priority queue. You guys all see this? Yeah. Okay. I'm gonna create a priority queue based on the end time of the meeting or the end time of an interval. Basically, I'm gonna create a class to make it a little bit easier to visualize. Is it hard to see?
Sort of like these off.
Yeah. There you go. Okay. So yeah, I'm gonna make a meeting room class. That's just gonna have start and end because it's easier to visualize like that. You don't need to do this. You could just do it by intervals, but whatever. I'm gonna make a meeting room PQ based on end time. And so basically what I'm gonna do for this is since each meeting is already sorted by start time, I'm gonna check. Each interval is sorted by start time. I'm basically gonna check for each interval which meetings get freed up. So if a meeting ends before the current start time of the interval, then I don't need to have a meeting. Like I can just delete that. So that's what I'm gonna do in my for loop. I can never spell priority queue. Meeting room. And then in this, I'm gonna define my comparer function. And this is just stuff like you can do it in a different way with like in Python, it's all different, but for Java, you have to define like this compare function that I'm doing. And so basically this is going to be based on end time. So that's why I'm using 1, which is the end time. So now I'm going to take the num. Whatever. Yeah, I'll do this camel case. Rooms, and that's going to be 0 at first. And then I'm going to go over each interval. This is already sorted by start time. For interval in intervals. And then I'm going to remove meetings that already happened. whatever. I don't think that's not how you spell happen, but so while PQ dot peak, while the first element ends before the current start date. So ends. Yeah, while the start date is bigger than the end day, I'm gonna remove it. Interval of 0. Yeah, so I'm just basically removing meetings that already happened. I don't know if this is the right function. So I get confused in Java and Python. Yeah, I think it's this. Okay. So while the priority queue isn't empty and the top element is less than the interval. All right. I'm going to remove it. Just make sure. Oh, it's dot end. Yeah, less than or equal to current start day. Yeah. Dot end. Okay. So I can remove meetings that already happened. Q poll. And then so yeah, this will remove all meetings that have already happened. Now I'm going to make a meeting. I'm going to add this meeting to the priority queue. I think I have to make this capital or whatever. Yeah, no problem. So I'm going to create that, set start end. All right. 0 and dot end equals 1. Okay, now I'm going to add this meeting to priority queue. So I removed all the ones that have already happened, and now I add the current meeting. And then I'm going to update the meeting rooms, the number of meeting rooms, and that's just going to be at worst, it's going to be the maximum size of the priority queue. Okay. So that's, you go over all the interview intervals, and then you just return it. That makes sense. Let me make sure it works. Where? Oh, it's supposed to be public class, maybe? Oh, no. Class. A B. I have to define these. All right, what am I missing? Oh, yeah.
Oh. For each.
I don't think you need to define that. Should work without it.
Yeah.
Well, you don't have to. All right, well, let me just get my solution. This is my solution, so there's not anything different. Yeah, it's just annoying sometimes. Let's see. Undeclared. What am I missing? Well, what am I missing? Well, I don't need to check if it's only one, like, it's fine.
Well, do you have a priority queue on?
Oh, you know what? I'm missing an extra. Just have that. No, the priority queue's right here. Well, it's always like this. Undeclared. Oh, I'm in C++. Oh my gosh, I'm an idiot. That's no wonder. Okay, well, here's my solution. Yeah, I'm just dumb. Okay, well, I'll make some comments. Well, it was working. It's just a log language course. Okay, so yeah. You do the base cases. The minimum mediums is going to be 0 at first. You're going to have a priority queue based on end time for the meetings. You're going to sort based on start time. Then you're going to iterate over all the intervals. And you're going to remove meetings that have already happened. So I might have done this the opposite way, but it ends up the same way. For and remove meetings that already happened. So yeah, you remove them, then you add the current one, and then the minimum number of meeting rooms is just going to be the maximum size of the priority queue, and then you're going to return that. Does that make sense to everyone? Yeah, I can go through an example if you want. And then this is going to be n log n. This is going to be O of n right here, and then this is going to be O of log n. So this is going to be at most n log n right here in the worst case, but it's not going to be multiplied by the for loop because it only happens once. So it's not like, I mean, I guess you could say the worst case is, but the like data n is not. At most, you're going to be adding and removing n times, and each n takes log time. So this is going to be n log n, this while loop. but it's not multiplied by this for loop because it only can happen like at one time. Like you can't add n meetings every single n times because there's only n meetings. So this is a little confusing, but this for loop isn't going to make this n squared log n. And then adding it is log n. And because it's a priority queue, and then, yeah. Does that make sense to everyone? Yeah. Next time I'll check if it's in Java or not. I was like, what's wrong with this? Yeah. So yeah, this is I got this question and I just like had no idea what to do. It's a hard question. Like if you've never seen it before. Sometimes it's all just straight how many Leetcode questions you've done. The next one, this is not a premium one, so if you guys want to do it, it is non-overlapping intervals. If you Google that, yeah. Let's see. Oh, you know, I'll open it here and then remove the solution. Okay. It is. Okay, so yeah, for this question, you're given. Okay, so for this question, you're given intervals and you need to count how many intervals need to be removed to remove any overlapping intervals. So you count how many intervals overlap and you need to determine how many intervals to remove to make the whole set of intervals non-overlapping. So yeah, in this example, you have 1 to 2, 2 to 3, those don't overlap, that's fine. 3 to 4, they don't overlap. And then 1 to 3, which overlaps with these two. So if you remove 1 to 3, then the solution's fine. So that means one removal. And then for this example, all of the intervals overlap. So you just remove like 2 of them. So you remove the other 2. Yeah, and then this one, 1 to 2, 2 to 3 don't overlap. If the start and end date are on the same time, then they don't overlap. So you don't have to remove any for this. So yeah. What do you guys think, like, solution if you had any guesses? If you haven't done the question before. If you go back to this chart, basically, you want to sort in some way that you cut down the cases to 1 to 3 or 4 to 5, 4 to 6. And then once you have those cases, you just have to account for like 2 cases, basically. And those 2 cases just have this one overlap part. So that's how you make these questions a lot easier. Once you sort them, like you can pretty much like solve once you know how to sort them, the question becomes a lot easier. Like once you know that it's not going to be like in this example, like 1 to 2, 2 to 3, 3 to 4, like if you started by like scheduling these and then you had this one at the end, you'd be like, oh, what, like it's going to mess everything up. But if you had it sorted and you're like, all right, if I take, say, the first one as 1 to 3, or I did 1 to 2, and then 2 to 3, and then I had just 1 to 3, then you'd be like, and you can be like, all right, just throw that one away. So that makes it a lot easier. So yeah. You can do it in both, like you could sort by start and end date. You just have to change the like condition that you're testing for or that you're doing. So yeah, I guess I can get started on the solution. Are you working on it or no? Nice. Yeah. All right. So yeah, I'll sort this one by start by end date. So I get a little different from the other solution. So I'm taking intervals and then do the compare. One minus e of 1. Sort by end. Okay, so once I sort by end, I'm gonna have 1, 2. Just copy this down. I'll have like this. It goes in increasing order. This one's gonna go right here. So this one is gonna look like now. This one's gonna look the same. But now we basically cut it into the 3. Well, I guess it's 4 to 6 now, but well, it ends up just being 1 to 3, whatever. Yeah, it's 4 to 6. So yeah, now we have like 3 possible cases. The case where B ends after A starts, or A starts before B ends, and then they don't overlap. So to do this, so this already takes n log n time. So I'm just gonna go over all the intervals, and I'm basically going to check yeah. So what I'm going to do is I'm going to take the current end day. I'm going to keep track of the current like max end day, and I'm basically going to check, is the next interval, does it start before the current end day? So if it starts before the current end day, then it's going to be an overlap and you're going to want to remove it. And then if that happens, then you want to take the minimum end date. So if you have an interval like 1 to 2, and then you have something like 1 to 5, and then let's say you have 2 to 3, and so on, you're going to want to, it's going to be sorted by end date. So yeah, it's going to be sorted by end date, so it's going to look like this. So for the first one, you're going to pick this, just no matter what. And then for the next one, you're not going to have an overlap, so it's fine. Let's add another one. 1 to 5, say 4 to 10. So for this, you're going to want to get rid of, so these 2 are fine. Then you're going to want to get rid of these 2 intervals, right? So you schedule these first because they go by end date. And then when there's an overlap, So right here, there's an overlap. You're gonna want to take the current start day to be the minimum of these two. So basically, you're gonna throw out the one that that ends the latest. So you're gonna always pick the interval. If there's an overlap, you're gonna throw out the interval with the highest end day. So you're gonna want to stick to like the 2 to 3. So you want to keep your current end as low as possible. So that's what I'm going to do here for interval in intervals. So I put overlaps as -1 because I don't want to start at I equals 1 because it's annoying. So the first interval is always going to overlap. So what I'm basically going to check here is if interval of if the current interval starts after, no, if it starts before the current end. So it's already sorted by end date, so you don't have to worry about that. So all you have to worry about is if the current interval starts before the end date that you're keeping track of. So in this case, you're going to increment overlaps. So you're going to get rid of an interval and you're going to set, and you're going to update end. So you're going to want to pick the end date that is the earliest. So you're going to take the min of those two. And then in the other case, in the case that they don't overlap, you're just going to update the end to the new interval. So in that case, there's no overlap. You don't have to worry about it. And then that should give the answer. Make sure. Okay, yeah. This is a little bit different from how Leetcode does it, but I find this is a little bit easier to teach. Let's make sure. Okay, yeah. So yeah, you could have done it by start or end date. You just have to change this one loop. So whenever you get an interval question, you're just going to want to check like, all right, how can I sort this in a way that makes it easier to solve? So the way I sorted it was by end date, and then I only had to check if the next interval started before the current end date. But if we look at the Leetcode solution, we got some like DP, whatever, it's stupid. Here. All right, here, greedy approach. Okay, so the first approach number 4, they use starting points. So yeah, they sort by starting points, and then it cuts down into the first 3 cases. So, you know, the cases that I have here, it's just right there. So sorting is that, case 2, blah, blah. And then for their code, they sort it. Then they just do the opposite. They check if wow, this is kind of confusing. They do the previous interval ends before, all right. Okay, the previous interval ends after the current interval starts. And then you get rid of one of them. And then this is just their update thing that I had, the math.min. So yeah, in that way, they just keep going like that. So this is basically what I did. They just did the opposite. They sorted by start date and then checked if the current interval starts after the previous interval ends. So yeah, it takes n log n time. And then how I did it based on n time is just the reverse. They do it the same way, like that. Yeah. So does that make sense to everyone how I did it? So yeah. pretty good. And I got one more insert interval. See how long it's got. Let me open it here so I don't. But does anyone have any like general questions or like any questions about interval or anything like that? Before I do this one. Okay. For this one, you are inserting, oh, you're merging intervals. You have a new interval and you have old intervals, and you are inserting the new interval and then merging the other intervals. So for this, you're just going to want to kind of do I haven't done this one in a while. Okay, yeah, for this one, you're going to want to find where the current interval is supposed to go. Is this sorted at all? It's sorted in ascending order by start date. Okay. So you're gonna keep a list. I'm gonna make a list because it's gonna be a little easier. Just a result. Okay. So you already told that it's sorted by start day. So it goes the earliest start day to the latest start day. So I'm just basically gonna insert this interval into where it's supposed to go. Keep it in index 0. So while index is less than intervals length, I think. And yeah, all right, what I'm doing is right. So yeah, I'm just gonna basically check if okay, yeah, I'm basically gonna add all the intervals that come before the new interval and into the new list. So these are going to be the ones that don't have any conflicts. Okay, so index, and then I'm going to check the end day and make sure that it ends before the new interval starts. So the intervals that you're given, you're going to assume that you don't need to merge any of them. And anything that comes before the new interval, you want to, yeah, anything before the new interval, you're going to add to this list, the result list. Rules of index. So these are all the intervals that you don't have to worry about, basically. You add that to the list. And then now you're going to want to merge them. So you're going to add the start of the new interval, 0, and the end of the new interval. Okay. So you know that you've already gone through all the ones that start before it, or that end before the current one starts. So now you're gonna go and you're gonna merge all intervals that conflict with it. So you again do the wall index less than intervals dot length and intervals start or end intervals index is okay. So now you're basically going to check all the intervals that start before the current one ends. And you're going to merge them. So to merge them, you're just going to take we're going to take the start date that starts the earliest. So it's probably yeah. It's either going to be the first interval or the middle interval, but you're going to take the lowest start day and the highest end day. 0. And end equals max and okay. So this is basically going to just take the longest interval. You just want to take all the conflicting ones and just extend into one interval. So once you have that, you can add it to the result as a new interval. Right. And so yeah, that handles, so this handles all the ones that are before the new interval. This handles all the ones that conflict. And now you just have to handle all the ones that, all the other ones, like anything after the new interval. So for this, you just need to just basically iterate through the rest of the list and add it to the result. Of index plus plus. Okay, and then because it's asking for a 2D array, I'm just going to convert my array list to a 2D array. And that's just going to be the size of the result list. And 2. So then I'm just going to return result 2 array of answer. Yeah. Okay. That should work. Okay. Yeah. Does that make sense to everyone? What I'm doing? I'm just basically, since it's already sorted, I only have to worry about these 3 conditions, 1, 2, and 3, and each. So the first while loop I have basically just takes, all right, I have some B, that's the new interval, and I'm just going to add all the intervals that end before the new intervals start. So once I have that, it's good. Then the second while loop, I'm going to keep track of the start and end dates for this whole conflicting interval. I'm just going to basically create a new interval that encompasses any that conflict with the new interval. And so to do that, I'm just going to take the minimum start day of any interval between any start the minimum start day and then the maximum end day. And just make that its own long interval. And then after I have that, that basically merges all the conflicts. And then I add the rest of the intervals after that. Does that make sense? I can maybe do a little example for this. Let's see, 1, 2. See, let's do 1, 3, 2, 4. All right, so for this one, let's say the new interval is this one. The start day is going to be 2, the end day is going to be 4, and then while the intervals of 0, which is the start day, is less than or equal to the end day, I'm going to make a new, like, merge it. So the start is going to be the minimum, it's just going to be 1. The end is going to be the maximum, which is going to be 4. So the new interval is going to end up being 1, 2, 4. Okay. Does that make sense to everyone? But yeah, these can be a little tricky when you first look at them. And then once you've done like 2 or 3, it kind of is like, all right, it's all kind of the same. You just have to basically memorize this graph or this picture and manipulate the problem to cut down to like 3 cases. So yeah. All right. That's all I got. Does anyone have any like general questions or like anything Leetcode, like or like job related or getting an internship, whatever?
Do you ever see questions that are written called maximizing out the number of intervals, but like the size of intervals? Because that would be might be right.
Like, what do you mean, like maximum profit? Or like,
You have intervals, but
Yeah.
then instead of just saying like how many, like the maximum number of intervals and all fit like one schedule without overlapping.
Yeah.
Maximum number not distinct intervals, but like like area you cover.
I haven't done a question like that, but I mean, you could just schedule based on, I mean, I think it might be, so you want the area, not the maximum intervals.
So it's like a bigger interval.
Yeah, I think that might be DP. Like you could maybe try the like, I think like longest interval might work. But it might not. Let's see. Let's say you have a long one. Like the longest one's here, and then yeah, I think it might be greedy. You might be able to do it with greedy, with just based on like longest interval. But if you add like profit, so like a question I've done is where you take jobs and you want to schedule the jobs that have the most profit without overlapping. That's a DP problem. Yeah. Let's see. At the end with the return statement. Oh, so right here, I'm just turning it into an array. Like this question wants a 2D array of integers, and I used a list, which is like easier to work with, but like Leetcode is just going to be annoying. If I return a list, it won't let me. So that's the only reason I use that. I would have rather like return the list. Yeah. Yeah, anything else? I think I'm gonna